One of the most important factors in laser diode packaging is temperature control. So how do you stabilize wavelength? So temperature and wavelength are linearly correlated. As the temperature rises, the wavelength also rises. So if you keep it fixed, the emission wavelength also remains fixed. Applications for data interconnect, metro, long-haul applications, a lot of those applications require very precise wavelength. Tolerances of up to plus or minus 0.01 nanometers is often required. And the only way to achieve that is by using thermoelectric technology. It's literally the only technology that can give you the super precise temperature control. TECs can also help control with optical alignment and diode health. We had people coming to our booth talking about challenges with optical alignment. When you keep the laser cool, it lowers the dark currents, and this basically cuts out waste heat and electrical stress. Those are the two key accelerants to laser wear out. So control temperatures can lower the junction temperature, and this can reduce the amount of input energy required to power a laser, which allows you to achieve the desired output with a lower input power. It can also cool faucets, so these can get heated up as light penetrates through them. You can also have oxidation as temperature rises, so by keeping them cool, it slows that down. And then there's also lower mechanical stress. So you all know when you go through heat cycles, solder joints, package integration, each of those surface layers, the CTE mismatching as you heat and cool can degrade those products. So by using temperature control, you can keep them fixed and lasting longer. What TEC are you using for 800 gig modules? And the answer for that is there is no standards. We typically work around engineered to order, and there's a good reason for that. One of them is there's a number of lasers that can be used in the application. So you can have 1, 4, 8, 2x4. Depends on the technology that's used, whether it's indium phosphide, EML, silicon photonics, or some hybrid of both. Reach has a big impact on the laser power. So you could have FR, ER, or ZR, but the further the distance you need to travel, the more power that's required in the laser, so that increases the heat pumping capacity. The optical modulation impacts the heat load, so whether you're using IM, DD, PAM4, or coherent. And then you also have the temperature rating, so you can use the iTemp or CTemp, and the difference between those two is about 15 degrees C, so that's a big shift. So you need to really understand all these parameters, assessing the active and passive heat loads, the TEC form factor limitations, how the product is integrated into the package, what the case temperature set point is, and a lot of the end customer application requirements to really dictate what type of TEC that you need. When we engage customers, we like to work with a design modeling tool. Often they'll send us a spec of a competitor's product and say, hey, can you match this? It's not a recommended way to go. Reason for that is our material properties are different than the competition, and also their data set values may not be accurate. Usually when you calculate thermoelectrics, they're based on a theoretical calculation, and they're just not accurate. So our preferred method is to actually understand your operating set point condition, and from there we can understand the thermal resistance of the hot and cold side, what's the desired heat pumping capacity requirements, and then start getting into more of the passive heat load requirements. The chart to the right goes into, again, the trade-offs. The red chart covers the efficiency of a thermoelectric cooler, and the purple chart covers the heat pumping capacity. So if you want more heat pumping capacity, your efficiency goes down. If you want more efficiency, then your heat pumping goes down. But we essentially optimize the design, which is not trivial. It's actually quite hard to design very small parts and get the proper thermodynamic modeling out of it to where we maximize the COP and achieve hitting your heat load requirements.